Okay, what we're going to look at here is applying the binomial formula. Now this is a continuation of the video I just made showing where the binomial formula comes from. Okay, so don't be confused by the numbering here. Okay, this is just examples of how to apply the binomial formula. Okay, so for example, in a poll, suppose 36% said they thought that George Bush did a good job as president. Let RV, X, that means random variable X, represent the number of people who say President Bush did a good job. So part A, suppose 20 people are randomly selected. Find the probability that exactly 8 said they thought Bush did a good job. So, okay, when we look at this, we have to recognize it as binomial. So first of all, are there a fixed number of trials? Yes. We asked 20 people. So that is your n value. Okay, so that's the number of trials. We picked 20 people. Okay, and then, do we only have 2 possible outcomes for each trial? Well, we're basically saying a success is somebody that said Bush did a good job as president, and a failure would be someone that said he did not do a good job. So we can classify each trial as a success or failure. The third thing was find the probability of success and failure on each try. Well, the probability of success, 36% said they thought Bush did a good job. So that is your P, okay, probability of success. And then 1 minus P would be 1 minus 0.36 or 0.64. Okay, so P would be 0.36, 36%. And 1 minus P would be 64% or 0.64. Okay, so to set this up, if you think about it in common sense ways, rather than using this confusing formula, remember the binomial was n, oops, I forgot to mention, the trials are independent also. You can assume that the population was large enough where we can assume independence. Okay, when you think about the binomial formula, NCX, P to the X, and then 1 minus P to the N minus X. Okay, that was that confusing binomial formula. Okay, and that was the probability of exactly X successes. Okay, well, if we think through this common sense-wise, we have 20 people. You want to choose 8 successes. The probability of success on any single try is 0.36. You need 8 of them. The probability of not a success on any single trial was 0.64. And you need 12 of those. Because if you had 8 successes, that meant there were 12 failures. Okay, so again, rather than try to memorize that crazy formula, okay, thinking through it common sense-wise, I think will make it a lot easier. Okay, now to do this on your calculator, to do the 20C8, so basically saying if you chose 20 people, how could you organize 8 or arrange 8 successes or 8 people that said Bush did a good job? So for example, if you listed 20 people, you could have the first 8 said he did a good job and then the next 12 said he didn't do a good job. Or you could have the first 7 say good job and then the 8th person not a good job, 9th person good job, and then the rest not a good job. So rather than list all those out, okay, I don't know what you have to do for the next week and a half, but combinations are the way to do this. So you put in 20C8. So you put 20 and then go to math over to PRB for probability and then NCR 8. Okay, so 20 NCR 8 will be 20C8 and that is 125,970. And then you want to multiply that by 0.36 to the 8th. So we're going to do times 0.36 exponent 8 times 0.64 exponent 12. And that gives you 0.1678. Okay, generally we're going to round these to 4 decimal places. So I'm just going to say 0.1678. So approximately 1678. Okay, if you use your calculator on this, we could use the binom PDF. Okay, and I'll just write that out. Or if you use a calculator, binomial PDF, you have 20 people. The probability of success on any single try is 0.36, and you want 8 successes. Okay, so we go to distribution, scroll to binomial PDF. There were 20 trials, comma, 0.36 was the probability of success in any single trial, and then you wanted 8 of those. Okay, and you notice it's the same thing we had when we did it by hand. Okay, part B, find the probability that 3 of the next 5 people selected said Bush did a good job. Well, very similar to the last one. If you think your way through it, okay, what you're basically looking at is there's 5 people. You want to choose 3 successes. The probability of success in any single case is 0.36, and you want 3 of them. The probability of failure in any single case is 0.64, and if there's 5 total, you would need 2 failures. Okay, so when you do 5C3, again you do 5, press Math, over to PRB, to NCR, choose 3 of them. That'll give you 10 times 0.36 to the third times 0.64 to the second. And that gives you 0.1911. Okay, using the calculator, with the binomial, you would have binomial PDF 5, 0.36, 3. And that would give you the same answer. Okay, I'm not going to go through the steps on that again. Okay, part C, if 8 people are selected, find the probability at least 1 says that Bush did a good job. Okay, so this one's a little bit different because of the wording. At least 1 said Bush did a good job could be how many? Well, at least 1 could be 1 or 2 or 3 or 4 or 5, all the way up to exactly 8. So if we wanted to, we could do 8C1 and then 0.36 to the first times 0.64 to the seventh. Find an answer for that and then add 8C2, 0.36 to the second, 0.64 to the sixth, plus 8C3, blah, blah, blah. That's going to be a lot of work to do. So what we look at is at least 1 could have been 1 all the way up through 8. The only other possibility is the complement, which would be exactly 0 said he did a good job. So we are going to do 1 minus the probability of exactly 0, which would be 1 minus, out of the 8 you're going to choose 0 successes, times 0.36 to the 0 successes, times 0.64 to the 8th. Okay, and when you do that, that would be 1 minus, okay, when you do all this in the calculator, you're going to get 0.0281. So 1 minus that will be about 0.9719. Okay, so that's an example of using the complement. Okay, so the complement of at least 1, the complement is 0. Okay, and that'll lead us into the next important thing. We noticed in the calculator when we did the binomial PDF, right below that was a binomial CDF. Okay, binomial CDF. Okay, what that'll find is the cumulative probabilities from x equals 0 through the value entered for x. This function is helpful when you use quantifying words like less than, at least, more than, etc. Okay, so when you have several of these probabilities that you would have to find and add them up, okay, we're not going to do more than 2 or 3 of these by hand. Okay, so we don't want to have to do like this calculation several times and then add them up. So that's what the CDF, okay, the binomial CDF, cumulative, will do for us. Okay, the CDF stands for cumulative density function, okay, which is way beyond what we need to worry about in here. If you're wondering why it says CDF, remember that C means cumulative. Okay, so an example of that, if 10 people are selected, find the probability that less than 4 of them said that Bush would do a good job. Well, less than 4 of them could be 0 or 1 or 2 or 3. Okay, it's not 4 because 4 is not less than 4. Okay, 3 is the first value that's less than 4. Okay, so on that one, you could do each of these probabilities separately. So basically, you can use this formula 4 times and then add the results together. But we're going to use our calculator, and we're going to go to binomial CDF. Okay, and it's NPX. Well, N, there were 10 trials. 0.36 is still the success on any single trial. And we want to go up and include all the way from 0, okay, from x equals 0, to the value entered for x, in our case, will be 3. So we're going to put a 3 there. Okay, so binomial CDF, 10, comma 0.36, comma 3. Okay, so just to show you real quick on the calculator, go to our distribution. Again, we're going to choose binomial CDF. And then we're going to do 10, comma 0.36, comma 3. And what that's going to do, because it's a CDF rather than PDF, it's going to find the probability of 0 plus the probability of 1 plus the probability of 2 plus the probability of 3, do it all at once, and give us 0.4868. Okay, now what that represents is the probability of less than 4 of them saying Bush did a good job. Okay, so that's what we wanted, 0, 1, 2, or 3, and that's what our binomial CDF will find. Okay, so that one's not too bad. Okay, the next one, it says, if 10 people are selected, find the probability that at least 4 of them say Bush did a good job. Well, at least 4 of them, at least 4 could be 4, or 5, or 6, all the way up to 10. Now this one's a little bit trickier because remember our binomial CDF finds from 0 up through the number that we put in. So in the last case, found from 0 to 3. So if you look at the complement of at least 4, the complement is 0, 1, 2, or 3. We just found that in part A. So we would do 1 minus binomial CDF, 10.36, 3, which would be 1 minus our answer from above, 0.4868, which would be 0.5132. Okay, so that one was a little bit trickier. Okay, people miss that at least all the time. Okay, you just got to kind of slow down. I think if you listed your possibilities out like I do here, and then think about, okay, at least 4, could be 4 or 5 or 6 and so on, then it's not as bad. Okay, then part F, it says if 20 people are randomly selected, find the probability that x is greater than 5. Well, greater than 5, that's basically saying that 6 or 7 or 8 all the way up to 20 said he did a good job. Well, again, using the binomial CDF, that would find from 0 up through a number. Well, notice what we're missing here, 6, 7, 8 all the way up to 20. What we're missing is 0 through 5. So that is what we need to find, and then subtract it from 1 to find what we're looking for. Okay, so if we're trying to find 6 through 20, then we have to find 0 to 5 and subtract it from 1. Okay, so that would be 1 minus binom CDF 20.36, and then up through and including 5. Okay, and again, you can do this on the calculator. It'd be 1 minus 0.2171, which is 0.7829. Okay, and again, we did the 1 minus there because we didn't need the 0 through 5, but unfortunately that's what the calculator finds for us with the CDF function. We needed to find 6 through 20, so because we had 6 through 20, we had to subtract the probability of 0 through 5. Okay, so that's why it's 1 minus. Okay, on the next page, okay, last thing we look at here with binomial situations or binomial distributions is we have a mean, a variance, and a standard deviation. Okay, so when you look at mean, mu equals n times p, so you take the number of trials times the probability of success in any single case, variance, np times 1 minus p, and the standard deviation, sigma, is the square root of the variance. Okay, so to find the mean, variance, and standard deviation of the spinner situation from number 2, okay, so if we go all the way back to that example, I gotta find it here. Okay, remember the spinner situation in number 2 was remember this was the table that we had for it. Okay, this goes back to the other worksheet, or the other video I should say. Okay, so to find the mean, mu equals n times p, well, we had 4 spins, so mu is 4 times the probability of success. Probability of getting a red in any single spin was 0.2, so that means that the mean is 0.8. Okay, for the variance, sigma squared is np times 1 minus p, so that'd be 4 times 0.2 times 0.8. So sigma squared would be 0.64. And then sigma, the standard deviation, will be the square root of 4 times 0.2 times 0.8, which is the square root of 0.64, which is 0.8. Okay, so again, that just went back to this situation here. Okay, and then suppose we have a 6-sided die, we're going to roll it 8 times. Let random variable x represent the number of 2s or 3s. So we're going to roll the die 8 times, so that is our n value. Okay, that's the number of trials. Random variable x, the number of 2s or 3s, so that means that p, the probability of a 2 or 3, is 2 out of 6, which reduces to 1/3, and then 1 minus p would be 4 out of 6, or 2/3. So to find the probability that x equals 5, that's basically asking you if you if you roll a 6-sided die 8 times, what's the probability of getting exactly 5 2s or 3s? Well, out of 8 trials, you want to choose 5 successes. The probability of success in any one roll is 1/3, and you want 5 of them. Probability of not a success is 2/3, and you want 3 of them. And if you do that, you get 0.0683. Now, I'll caution you here, do not put 0.3 or 0.33 in the calculator. Write it as a fraction. Okay, so put 1 divided by 3 in parentheses, raised to the fifth. Okay, don't say 0.3 or 0.33 and then 0.66 or 0.67 for the 2/3. Okay, you want to leave it exact. If you did the binomial, okay, so the binomial in the calculator, this would be a PDF, okay, binomial PDF, because we want exactly 5 successes. So that would be out of 8 trials, 1 divided by 3 is probability of success, and you want 5 of those. Okay, and that will give you the 0.063. And again, do not round that. Okay, put it in as a fraction. The probability x is greater than 3. Well, to get greater than 3, you could get 4, or 5, or 6, or 7, or 8. Well, this is where you have to use the complement again with the binomial CDF, which will be 1 minus, out of those 8 trials where the probability of success is 1/3, well, 4, 5, 6, 7, 8, its complement is 0 through 3, so we're going to go up to and including 3. And when you do that, 1 minus 0.7414, which is 0.2586. Okay, and then to find the mean and standard deviation, the mean is n times p, which will be 8 times 1/3, which is 8/3. The standard deviation, the square root of 8 times 1/3 times 2/3, which is the square root of 16/9, which is 4/3. Okay, so there's the mean and standard deviation of when you roll a pair of 6-sided die 8 times, and x being the number of 2s or 3s.